I was asked to walk through question 6 a little bit. I think some people are still having a little bit of trouble with this. So 6 was about a soccer player kicking a ball. So I've laid it out in this diagram. The ball leaves his foot at a speed. It's listed there. So the first thing we do, as always, is break everything up into the horizontal and vertical components, and then list what we know and what we want to know. So let's start with what we know. We know that the goal is 28.2 meters away. So the horizontal distance is 28.2 meters. We also know that the ball leaves his foot with a speed of 18.9 meters per second, and the angle is 33.2. So we have to, if we're going to list this stuff in the vertical and the horizontal, this is one of those situations where we have to break it up. So you can see from the diagram, we've got an X component and a Y component. So let's break that down. So Vx, we can do it over here, say. Vx is equal to V cosine theta, which is, in our case, 18.9, cosine of 33.2. And then putting that into our calculators, we get cosine of 33.2, it's 15.8148, 15.8148 meters per second. And then in the y direction, Vy, and then in this case, we're calling this V naught y. Hopefully this makes sense to you. Hopefully by now you understand that in this pink vector that I've drawn here, it's referring to the initial conditions. In the vertical, the velocity is going to constantly change because the acceleration in the vertical is negative 9.8, right? Meters per second squared, meaning the velocity won't stay constant vertically, but that green arrow, the horizontal, it stays constant throughout the entire flight because there is no acceleration in the horizontal. So Vx is going to stay 15.8148 for the duration of the flight, meters per second. But the velocity in the y component is constantly changing. So when I solve it here, that's why I'm calling it V naught y. And that equals V sine theta, which equals 18.9 sine of 33.2. And then doing that math, we get sine of 33.2, 10.3489. 10.3489 meters per second. Honestly, all the V's are confusing. Why do I have a V and a V? Vx equals V. When I talk about this V, I'm just going to put a little red thing over here. Actually, this is the hypotenuse. This pink arrow that I'm talking about. And the green and the orange refer to the components. Okay, so the component, so when you kick the ball, when this soccer player kicks the ball at 18.9, part of that is moving it forward towards the goal, that's the green, and part of it is lifting it into the air, that's the orange. And that's why we split it up into the two different components. So I'm going to list my component here. The Vy, V naught y is 18.9. Sorry, it's not. It's 10.3489 meters per second. Okay, so I've put in the acceleration already in the vertical, 9.8 meters per second squared. I'm calling down negative and up positive. That's why my V naught y is positive, because the orange vector is pointed up. Now, there might be a temptation to put in something here. Like, do we know the vertical height? It doesn't tell us anything about it. So we actually don't know why. Because he could have caught it up in the air. He could have caught it at the same level. We just don't know. So what we do know is that we know two things on this side. We know this and we know this. So what we can do is figure out the time, and then the time is the same, right? So whatever I find for that time in the horizontal, I can plug it into the vertical. All right, so let's do that. So our equation is delta x equals v delta t. but I'm going to rearrange this to solve for delta t equals delta x over v, which is 28.2 divided by 15.8148. And for delta t, I get 28.2 divided by 15.8148. I get 1.78 seconds. 1.78, I'll just write a few digits, 31 seconds. All right, so then I'm going to plug that into here. So now I know, I'll put a box around this so you know that I got it from the horizontal. It's 1.7831 seconds. Okay, so now I know three things. I can ignore the delta y. That can be my don't know, don't care. And then my question mark is the Vy. So then plugging that in, so without the y, I've got V equals V naught plus A delta T. And I should put the y's in here just so we're clear on that. Vy equals, so the initial velocity was 10.3489 plus negative 9.8 times 1.7831. Putting that all together, so 10 point that minus 9.8 times that time, I get, oh, and then you're probably like, ooh, there's a negative sign. Is that right? Let's think about it. I'm getting an answer of negative 7.12577 meters per second. Okay, let's think about this. So looking at the blue arc here, the ball launches, it goes up, and at the instant I've drawn it here, it's doing this, right? This is the direction of the ball, the instant the goalie's catching it. And so what I want you to notice is there's a x component, and it's the same x component, because remember what we said about the green arrow doesn't change, but now there's also this down y component. And that is what this down y component is actually what we've just discovered, what we've just solved. This Vy is this orange vector, okay? So that is actually not what the question is asking us for. The question is not asking us for what is the y component, it's asking us for the hypotenuse. So let me just draw this out down here. Hang on, let me move all that down. Okay, so let me draw this out. So the instant the goalie catches the ball, it's doing something like this. It's moving down. We know the x component never changes. So the x component is still whatever it was before, 15.8148. Like we calculated before, meters per second. But now we've just determined this y component, and it is negative 7.12577 meters per second. So what I'm trying to find is this. This is my actual V that I'm looking for, okay, the final velocity. And so to do that, I'm going to use Pythagoras. So V equals, so final, oops, let me write this again. Final velocity is the hypotenuse, or the vector addition. I don't know how to spell hypotenuse, sorry. And what I mean by that is the vector addition of Vx and Vy. Okay, so then the final velocity V is going to equal the square root of 15.8148 squared plus, and I'm just going to leave it in the positive, and we can talk about that, 7.12577 squared. So that's my equation. So let me write that down. Let me calculate that, I should say. That's squared. Oh, shoot, clear. Let me do the math. Plus, and then 15, where's that? 15, sorry. I've got to put this all in my calculator. Plus, okay, quit clear. Okay, so 15.8148 squared plus 7.12577 squared, and then take the square root of all that. We get 17.3. V equals 17.3 meters per second. If you go back to the original question, it just says find the speed. Okay, so I don't know about the angle, and I don't care. If it had asked me find the velocity, I would need to know the angle below the horizontal. But as it is, this answer is good enough. 17.3 meters per second. Did I get that right? Oh, I didn't put the answer, but I think it's right. So if you got it wrong when you did it, maybe you only put in the component, I'm not sure, but that is the answer.